Hello everyone, welcome to this class. Today we have this challenge before us. The question says solve x to the power of 3 plus z to the power of 3 equal to y as our equation 1 and y to the power of 3 plus x to the power of 3 equal to z as our equation 2. Then z to the power of 3 plus y to the power of 3 equal to x as our equation 3. What is the value of x, y, and z that will satisfy these three equations? So if you're new here, this is my pros. If you've not subscribed, do it to subscribe. So we take our solution here. Okay, so we're going to solve this step by step. Okay. Now from these three equations, we're going to do some subtraction. So let's subtract equation 2, which is this, from equation 1. Okay, so let's put it and write it as subtract, subtract, rather, subtract equation 2 from equation 1. Okay, so here we're going to have our x to the power of 3, the plus z to the power of 3 minus bracket our y to the power of 3 plus x to the power of 3 close bracket. This will give us our y minus z. Okay, so we can use this to open this bracket. So we're going to have x to the power of 3 there plus our z to the power of 3 minus y to the power of 3. This time this will give us minus x to the power of 3 equal to y minus z. Of course, this and this will leave. So we now have z to the power of 3 minus y to the power of 3. This is equal to y minus z. Is it right? Okay. So from here, we want to consider our algebraic identity from this expression you have here. Remember that you have your a, take it here, a to the power of 3 minus b to the power of 3. This is equal to bracket a minus b plus bracket a to the power of 2. There plugs our a, b, there plugs our b squared. Remember this? Okay. So we're going to make use of this special algebraic identity. So let's rewrite this expression in this format here. So this is going to give us here, we're going to have our bracket z minus y plus bracket z to the power of 2 that plus zy plus our y squared plus bracket. Everything will now be equal to y minus z. Easy. Now, we want to move everything on this side to this side of the equation. So this will give us z minus y plus bracket z to the power of 2 plus our zy plus our y to the power of 2, then close bracket minus bracket our y minus z close bracket, everything equal to 0. Now you discover that here we are having z minus y and here we are having y minus z. So we want to bring this z to this side and take this to this side. And if we do that, this will come this way and here will turn to plus and this will turn to minus. So let's rearrange this. The essence of rearranging this, because of what we have here, we want to bring it out from here. So this is going to give us bracket our z minus our y plus bracket z to the power of 2 plus z y plus our y squared close bracket plus bracket z minus our y close bracket equal to our 0. So you now have this and this. So let's factor this and this out from the system here. So if we do that, we're going to have here bracket z minus y close bracket. If we use this to divide everything here, this will come out and we are left with it. So we now be left with our bracket, our z to the power of 2 plus our zy plus our y to the power of 2 close bracket, plus. If we use this to divide this, we are left with just 1, close our square bracket equal to 0. Then when I look at this, we cannot open what we have in here now. So we now have here our z minus y close bracket z squared plus, let's take our y squared, then plus our z y, plus 1 close bracket equals to 0. Now, from this expression, we apply the zero product rule. We say that if you have your A times B, this is equal to 0. This implies that our A is equal to 0 or B is equal to 0. So we're going to apply this rule to this expression. So here we're going to have case 1. We have here case 1. So from our case 1, we have our z minus y equal to 0. So it also means that our z is equal to y. Let's give this equation 4 because we have equation 3 there already. So let's give this equation 4 and hold this case 2. Our case 2, we have our z to the power of 2 plus our y to the power of 2 plus our z y plus 1 equal to 0. Now we've established that z is equal to y. So wherever we see z, let's put in y there. This will now give us here our z squared, then plus our z squared again, plus our z times our z plus 1 equal to 0. So here we can rewrite this as z to the power of 2, then plus z to the power of 2, plus z to the power of 2, plus 1 equal to 0. We have 3 of this, so this will give us 3z to the power of 2, then plus 1 equal to 0. Send this to this side, so we have 3z to the power of 2 equal to minus 1. Divide both side by 3, divide this side by 3 also. This leaves the system. So we now have z to the power of 2 is equal to minus 1 all over 3. We are looking for z, so we take the square root of both sides here. So immediately we do that, we add our plus minus. So this will leave the system. So we have our z will now be equal to plus minus the square root of our minus 1 all over 3. Now, we know that this expression we have here will be written as our plus minus the square root of minus 1 times square root of 1 all over the square root of 3. And we know again that the square root of minus 1 is equal to I. So we can bring I to the system. So this will give us here z will now be equal to plus minus 1 all over the square root of 3I. So we have two solutions from here now. So we have our z1 is equal to our 1 all over square root of 3 I, and z2 we have it to be minus 1 all over the square root of 3I. Yeah. So let's keep these two answers here. Okay. Now let's go again to our equation, what to do with the other equation. Now look at our original equations here now. So from here we want to subtract equation 2 from equation 3. So from here we now say subtract. Let's put it down here. Subtract equation 2 from equation 3. Okay, this is our equation 3 please. Okay, so for us to subtract equation 2 from 3 is easy. So again, let's look at our equation 3. We know this is our equation 3 and this is our equation 2. So this is going to give us here our z to the power of 3 plus our y to the power of 3 and minus bracket y to the power of 3 plus our x to the power of 3 close bracket. Everything will now be equal to x minus z. So if we open up this, we're going to have here z to the power of 3 plus our y to the power of 3 and minus y to the power of 3 minus x to the power of 3 equal to our x minus z here. So this leaves the system. We now have here z to the power of 3 minus x to the power of 3 equal to x minus z. Now, again, we remember what we did the other time. Okay, so we now apply the difference of two cubes. So if we apply that to this is going to give us here our bracket in z minus f plus bracket z to the power of 2, then plus our x z plus our x squared plus bracket minus, here we want to move this term to this other side straight. So we have here x minus z. Let's put this in bracket, everything equal to 0. Again, we rewrite this to have something of this nature here. So good to give us here our z minus x plus bracket z squared plus xz, then plus our x square plus bracket, then plus bracket our z minus x plus bracket, everything equal to 0. I will learn something here. I want to factor out z minus x here. So this is going to give us z minus x plus bracket. Okay, then this will now be bracket left with x to the, z to the power of 2 plus our x z plus our x to the power of 2. Automatically here is going to give us plus 1. So everything here plus 1 plus bracket equal to 0. Again, we succumb to the zero product rule, whereby we're going to have our z minus x equals to 0, or we have our z squared plus x z plus x squared plus 1 equal to 0. So here we now have this to be z is equal to x. Let's take this as our equation 5 now. Remember, we solve our equation 4 to be z equal to y. Remember that? Look at it here. Okay, we've established this already. Now we've established another one again here right now. If we are saying that z is equals to x, and we've already established the fact that our z is equals to y, so what does that imply? It does mean that, or let's put here, it does imply that our x is equal to y, which is equals to z. Okay, this is equals to z. Okay, so let's give this equation 6. Okay, let's hold this now. Now, from this equation now, let's go back to our equation 1. So we can now say from equation 1, from equation 1, so what we do here now, let's record our equation 1. Look at our equation 1 here. This is our equation 1, right? So from our equation 1, let's write this equation 1 out first. So we have our x to the power of 3 plus z to the power of 3 equal to y. So seeing that we establish the fact that x is equals to y is equals to z, so we can put in x here, put in y x here also. So this is going to give us here x to the power of 3 plus x to the power of 3 equal to x here. So we have here 2x to the power of 3 equal to our x. Move this to this side of the equation. So this is going to give us here our 2x to the power of 3, then minus x equal to 0. Factor out x here, so we have x bracket 2x to the power of 2 minus 1 equal to 0. So again, we have two cases from here. We now have our x is equal to 0, or 2x to the power of 2 minus 1 equal to 0. So let's keep this. Then we now take this case scenario. So we have here 2x to the power of 2 minus 1 equal to 0. So we have send this to this side. I have 2x to the power of 2 equal to 1. Divide both side by 2, divide both side by 2. Cancel, cancel. So I have x to the power of 2 is equal to 1 all over 2. We take the square of both sides. The square root of both sides. So take the square root of both sides. Again, we produce our plus minus. So this will leave. So we now have our x is equal to, this can be written as plus minus 1 all over the square root of 2. Easy, right? Good. So this is another value for our x. So here we have our x1 here, and here we have our x2 here. So in all, what are the values that will satisfy these original equation, which is where's our original equation, which is this very guy here. So let's go ahead and bring out all the values. The first value we solve for is this one here. Okay, so it tells me our x, put it here, our x, comma y, comma z, bracket will now be equal to, one of them is 0, right? Okay, but let's start with the one that has 0, which is this very one. So this is going to give us here bracket 0 comma 0 comma 0. Okay, the next one to it we have um positive x. So this is going to give us here 1 all over the square root of 2 comma 1 all over the square root of 2 comma 1 all over the square root of 2. Okay, then we have the negative to this also. So this is going to give us minus 1 all over the square root of 2 comma minus 1 all over the square root of 2 comma minus 1 all over the square root of 2, close bracket. And the last one, which is imaginary root, is this very one here. So this will also give us here bracket positive 1 all over root 3 iota, comma 1 all over root 3 iota, there, comma 1 all over root 3 iota. And lastly, we have bracket minus 1 all over root 3 iota, comma minus 1 all over root 3 iota, there, minus 1 all over root 3 iota. Okay, so these are the roots we have or we solve for that will satisfy the original equation. Okay, so this brings us to the end of this challenge. If you have learned something from this video tutorial, give the video a thumbs up. And if you are not clear with any of the steps we apply in solving this challenge here, drop it in the comment section, even as we are there, to reply to all your comments. Remember, this is my prowess, and we all here, we love you dearly. Thanks for being there. Bye.